Assalamualaikum and hi, my name is Putri Syamimi Wali binti Samsul. My metric number is 191392561 for FYP. My title is Textile RFID Antenna for Early Breast Cancer Detection. As everyone knows, cancer is one of most deadly diseases, especially when it turns to malignant and infiltrates the body, cause it to spread to another organ. Breast cancer is a disease in which cells in the breast grow out of control. It called as a abnormal tumor, so it difficult to detect even with advanced technology nowadays. Breast cancer is one of the most frequent type of cancer in the world, and it kills a lot of women. Well-trained physicians can spot this tumor through a serious exam, but sometimes it can be misread the scan result or scan mislead. Many methods include as a mammogram, MRI, and ultrasound to detect, but due to the weak contrast, these technology are of a little use in identify cancer at early stage. There are some techniques has been used to detect, such as microwave imaging and radar-based microwave tomography. Radio frequency identification, or what we call RFID, is a wireless technology that unequivocally identify and track target object. It aims to determine a feasibility of using RFID based intraoperative instrument tracking as an effective means of early breast cancer detection. According to the National Breast Cancer Foundation report published in 2015, breast cancer is one of the major cause death for women worldwide. Due to the restricted availability of clinical imaging, research are actively investigating several methods for early breast cancer tumor detection. The microwave imaging technique is an alternative solution to identify the breast cancer because it allows low purchase price and easy of use, and effectiveness in locating and detecting this tumor. Flexible feature of microwave imaging device is another important factor to be considered. A 16-element antenna array operating with single and dual polarization in the shape of a breast proposed. The reflector element is placed at 1 cm distance from the antenna to improve its directivity. However, such distance between the reflector and the antenna is difficult to be accepted due to need a larger spacing. On the other hand, a flexibility CWP fit UWB antenna was proposed. Fractal topology is integrated into the antenna to enable high directivity and gain, resulting in a more complex antenna design. So the objective of this project is to develop textile RFID antenna of broadband at frequency 2.45 GHz and UWB ultra wideband antenna at frequency 2.89 GHz until 7 GHz. Next objective is to integrate the developed antenna and breast cancer phantom with intelligent breast cancer detection system based on machine learning. Third objective is to compare the performance of broadband and UWB antenna for breast cancer detection in terms of accuracy. So this is a flowchart for this project. First is a develop of microstrip patch and UWB antenna, and then we develop a breast phantom, which is two type of breast phantom. First is a normal breast, and second is a breast with a tumor, and then we integrate and simulate the microstrip patch and UWB antenna and with a breast phantom. So if the result is good, and then we compare the performance at 2.45 GHz for microstrip patch antenna and UWB antenna at frequency 2.89 GHz until 7 GHz. This is how to set up the project using machine learning. So we have two antenna, which is a microstrip patch and UWB, and then this is a breast phantom. We have two different type, which is a normal breast and breast with tumor. Then we connect the two antenna with a VNA. After connect two port, which is port 1 and port 2, vector network analyzer connect to the PC and PC to GUI. GUI is a graphic user interface. So from this result S21, we convert to discrete math using GUI. Using machine learning. This is expected result that we need to get from so after we implement the this is expected result we need to get after we develop and simulate on FYP tool. So for microstrip patch antenna, after we fabricate, we get a frequency around 2.35 giga at negative 24.10 dB. So this is a UWB antenna at the black line. The reflection coefficient behavior indicated that this antenna is a combination of several wideband resonant frequency at 3.0 GHz, 3.9 GHz, 4.9 35 GHz and 5.15 GHz, and then 6.32 GHz. So that's all for our project. Thank you.